Hey folks, so in this video we're going to be learning how to find the volume of certain 3D figures. And I'll go back to your formula sheet lightning fast here. You already know we've covered the 2D stuff, and we have already taken a look at surface area of the 3D shapes. So on your formula sheet in the previous video, we already covered surface area, which is all of these things. And today we're actually going to be looking at volume, which is these things. Okay? Now, the first thing I want to point out for the volume of any shape is that it's just the area of the base times the height. So you're going to notice that for all of these things highlighted here in green, that we take the area of the base and then we simply multiply it by the height, and we now found the volume. You'll also notice that for cones and pyramids, there's a 1/3 in the formula, so we're going to be dividing by 3 in those situations. All right, so let's kind of dive on in here, and we're in the packet. On this page, we have 4 shapes we're going to look at. All right, so for this first shape, it's a rectangular prism. And you guys know that the base of a rectangular prism, if I kind of trace it here for us, if we kind of see through, the base of this thing is just a rectangle. So yes, it's still the area of the base times height, but for this one, we get to use length times width times height. That's what you see on your formula sheet. Again, the base is a rectangle, so we've got length times width. And in red, that's going to be the 6 times the 4.5. And then the height of this prism here in blue is the 5. So in elementary school, you guys probably saw the prisms, and you loved volume of a prism question because you got to straight up just multiply 6 times 4.5 times 5. So in our calculator, 6 times 4.5 times 5. So for this volume, we get 135. Now in the previous video, when we talked about surface area, we did square inches. Since we're filling up this 3D shape, we've got length, width, and height. We're bound by 3 dimensions. So this one is going to be cubic inches. Volume is cubic inches, okay? And I'm saying the word cubic. All right, cool. So if it's a prism, no big deal. You've just got length times width times height. Now for this one, for a triangular prism, it is still the area of the base times the height. And you'll notice over here on the formula sheet, it just leaves that. It's BH. So for volume of the triangular prism, the base is a triangle. So we're going to do the area of a triangle and then times the height of the prism. All right, so for this one, we actually just get this formula from the formula sheet. Now the bottom is the right triangle that I'm tracing here, and it's the 6 by 8 right triangle. Okay, that's the base. So I'm going to do 1/2 6 times 8. And again, if this is the 8 and that's the base and this is the height of 6, it doesn't really matter because it's commutative. But I know for some of y'all it's really going to bother you that I put those in a different spot. So let me put that back. All right, so we've got the base is the 8 and then the height of that triangle is a 6. Now remember, this is just the area of the bottom part of the figure. That's what the capital B stands for. It's area of the whole base. Now the height of the prism is this thing here in blue. That's the 9. So we have a triangular bottom. The 8 by 6 is 48, and half of that would be a 24. So that's the area of my triangular base. And then now I'm going to do times the 9 for the whole prism. And that'll give us our total volume. So we've got 24 times 9. So we get a 216 for this one. So this volume is 216. And we've got meters, so I'm going to say cubic meters. The volume is 216 cubic meters. So if the bottom's a rectangle, it's length times width. If the bottom's a triangle, it's 1/2 base times height. And then what they both have in common now, because we're filling up a 3D shape, is in blue, multiplying by the height of the overall prism. Now I mentioned back here on your formula sheet, when we're looking at pyramids and cones, you're going to see a divide by 3, which is the 1/3. So let's take a look at these now, okay? When we have a cone, the bottom part is a circle, so it's going to be the pi r squared. We have times height, and then we're going to take 1/3 of it because it's a cone. Now let me draw real quick for you all. Let me draw a cylinder. Actually, let me get this from over here. I could get a cylinder. All right, so this cylinder right here, inside of it is the cone that we're talking about. I could kind of sketch here the cone that reaches this top part. And then I can kind of sketch here through the bottom. So if I were to take this cone and fill it up once, I would be able to, there would be three of them would fit in the whole cylinder. Okay. So if that cylinder, the original cylinder I just had, let's say I filled up the cone with water. And when I filled up the cone with water and poured it in here, I would fill it up a third of the way. I'd have to fill the cone up again and it would come to here. And if I took the cone and filled it up with water and dumped it in a third time, now I've got the entire thing filled up. So you'll notice that the cone is the cylinder just divided by 3. Pi r squared times height is the cylinder, and we're just going to divide that by 3. So in this case, we've got pi already. The radius here is a 10, and that was going to be squared. So this is the area of my circle bottom. Now the height of this thing I do not know. You used the 13 in the other video, the slant height, to cover up the outside. But now that we're filling up the inside for volume, I don't care about the 13, I care about the true height of the cone. Now I'm going to need to bust out the Pythagorean theorem and do my hypotenuse squared minus that one leg squared. So this is 169, and I'm going to minus 100. And then when we take the square root of this in the calculator and round it, that's going to give us the height. So the height's about an 8.3, about an 8.3. Okay, so I've got the height. Careful not to use the slant height. Slant height on the outside is for the surface area. Filling up the inside, we need the true height. And even though you see the 1/3 in the formula, me personally, I just like to put it all over 3. So in the calculator, we've got pi r squared times height, so 3.14 times, now 10 squared is 100, times 8.3. So that's my top part, y'all. Now, a third of that, I'm just going to do divide by 3. So I get 868.7. So the volume of this is 868.7. There's no units here, so I'm just going to put cubic units. And again, I feel like I might not have explained this part very well, but let's say you've got this cylinder and the cone that fits inside of it, let's say you fill the cone up with water and you're going to pour it into the cylinder. If you fill the cone up just the one time, it's going to go to about right here in the cylinder. If you fill the cone up twice and dump it in, you've got 2/3 filled up. And if you fill this cone up with water and dump it in a third time, now the entire canister is filled with water. So the relationship between the cylinder and the cone is that the cone is simply 1/3 whatever fits inside the cylinder. And it's actually the same thing. If I pull up a cube, let me get a prism. Let's see if it lets me pull a prism. This one, that one's going to be more of a rectangular prism. So let me just draw a cube real quick. Okay. You might remember from the other class I showed you guys this. There we go. Just assembling a cube real quick. So this is a cube, and the pyramid, a square pyramid that fits inside of it, would still have this same square bottom right here. This would still be the same. And it would come to a point right there in the center. So this pyramid that fits inside here holds 1/3 of what the original cube would have held. So if I tell you that there's a cube out there, if this cube, let's do that it's a 9 by 9 by 9. The cube is going to hold 9 by 9 by 9. So the cube holds this much. And then the prism, if I divide it by 3 for the pyramid, that would be 243. So the pyramid is a third of it. Okay. So now let me go back over here to your notes. And we're on this last example here. So for the volume of this one, once again, we're just going to find the length times the width. And then we need to do times the height. So the area of this base right here is going to be 8.4 times 12.5. So we've got length times width. We're going to be multiplying it by the height. Then we're going to be dividing by 3 or taking a third. Okay. So the length times the width, we've got 8.4 times the 12.5. That's my rectangular base. Now I'm going to do times the height of 7.3. Then all of that is going to get divided by 3 because I'm dealing with a pyramid. Okay. So in our calculator, for the top part, the numerator, we've got 8.4 times 12. Whoops, that was 8.44. Let me get that. 8.4 times 12.5 times 7.3. 819. Now that's the top part. Oh gosh, I did 7.8. Let me get that. There we go. No, this should be times 7.3. There we go. Now that's the top part. And let me just double check my math one more time because I feel like I saw that I double clicked the number there. So 12.5, 7.3. Cool. Yep, that's the top part. Then we're going to divide by 3 because it's a pyramid. So 255.5. And we've got cubic meters. So your formula sheet gives you everything you need to know. It's more about just comprehending that in the background, you've always got the area of the base times the height. And if it's a cone or a pyramid, just divide by 3. All right, so let's flip over to the next page. On this one, we have a cylinder to start out. So the cylinder, we've got the circular bottom, so that's going to be the pi r squared part. Then we're going to do times the height, which is the 7. So that's going to be this formula right here. We've got pi r squared, that's the red circle, then times the height. The radius in this one's going to be a 4, so we've got the 4 squared times pi. And then the height would be the 7. Cool. So let's see what we get in the calculator. We know 4 squared is 16 times the pi. So this is the area of the red circle. That's the bottom. Now, since it's volume of a 3D shape, I'm going to do times the 7. And I've now filled it up. I've got 351.68. So 351.68. And we'll put cubic yards. Okay. Friendly reminder that if it was the cone that went inside of this, then I would have done divide by 3. But it's not, so I don't need to worry about that. All right, now for the next one over here, we have a triangular prism, and it's a little tough to catch what's the top and the bottom for this one, so I'll remind you guys that it's whatever there's 2 of. So this triangle right here, there's 2 of those. So that's the triangular base. And we're going to do 1/2 base times height to get the area of that purple thing. Now the base is this 4, and the other leg, the 2 legs that make the right angle there are the 5 and the 12. So to help you kind of see it, this one's the 5, this is the 12, and then the 13 is the hypotenuse. We don't need the hypotenuse for the area. I can do the 5 by the 12. Now 5 by 12 is 60, so half of that is 30. So I found the area, of my purple triangle. Okay, I found the area. Now I want to do the height of the prism, which is this thing in blue. So I'm going to multiply this by the height, which is 5. So it's half base times height. that's the triangle, then times the height of the prism. And when we do this, we get a 150. Miles is how it's labeled, so 150 cubic miles. All right, now for a cone, again, we know it's going to be the circle times the height, but then I've got to divide that by 3 because it's a cone. So for the cone one, it's this formula. We've got pi. The radius here is a 5.7. The height is given to us, it's the 12. We don't need the Pythagorean theorem here. If I was finding surface area of this cone, then I would need the Pythagorean theorem to get the slant height on the outside, but I don't care about that. I'm not looking at the outside right now. This video is all about the inside, so I care about the 12. And then, like I mentioned, instead of putting a 1/3, I just like to do a big fat divide by 3 at the end in the calculator. So I've got pi times, oh, let me get my, I got to do 5.7 squared. I forgot about that. There we go. So let me start with 5.7 getting squared. Cool. Now we'll do that times pi. Now I'm going to do times 12. And that would be the whole cylinder. That would be the whole cylinder of this thing if this were a cylinder. But I'm going to hit divide by 3 now because it's a cone. And we'll let this be a 408.07. 408.07. And we can round that to the nearest tenth. I'll just review how to round to the nearest tenth real quick. Since this is a 7, I'm going to bump that up. So it'd be a 408.1. A 408.1. And we have centimeters, so cubic centimeters. And now for the last one. It's a triangular prism. And once again, we have a triangle that has 2 sides, so those are the bases. And then the height of this prism is this thing in blue. So for the area of the base, we've got 1/2, 8 times 3. And then we're going to multiply that by the 12. Now here in purple, 8 times 3 is 24. Half of that would be 12. And then we've got times the height of the whole prism. So for this one, we end up getting 144. And this is going to be cubic centimeters. Now, one thing that I want to review real quick, now that we've kind of finished taking notes here in the packet, let's say I tell you the volume of this cone is 100. And let's just say it's cubic centimeters. If I give you the volume of the cone and say, hey, what's the volume of the cylinder that has the same base? All you got to do, and I know my drawing is really jacked up here, so sorry about that. But all you've got to do then is say, well, if the cone is 100, then the cylinder would be 300. Okay? I could have started with the cylinder and said, hey, the volume of this thing is 300. So then I could say, what's the volume of the cone that's inside of it? And if that's the case, then you would just do divide by 3 to tell me the cone is the 100. Same concept, y'all. For a pyramid inside of a cube, I mentioned that here to you all. If I told you that the overall cube was a 729 and said, hey, what's the pyramid inside? You would just divide by 3. Or I could say, hey, this red thing in here has a volume of 243. What's the volume of the cube that it fits in? And then you would just say, oh yeah, I'll just multiply by 3 and get the 729 for the whole cube. So again, the third, I just wanted to review that for the cone and the pyramid. And that concludes this video. Thank you for watching.